always love to come to Vancouver. It's sort of the area that's on the cutting edge of whatever is going on in Agile. And I know I can talk about the new stuff we've been discovering here and not get run out of town, at least I hope. So Tom and I go around the world and we teach classes called, right now, the current class is called Leading Lean Software Development. And when we have class, the first thing we ask people is, what one problem are you struggling with at work that you hope you will have some light shed on by the end of this 2-day class? And then we make a list of the problems, and hopefully by the end of the 2 days, we address them. And the interesting thing is that over time, those problems have changed. We just came from traveling around the world for 6 weeks, and we got a sort of a really interesting batch of problems. But what people are talking about these days isn't close to what they were talking about 10 years when we started doing this. A large amount of people say, well, you know, done Agile, been there, see, 4 years into Scrum, but what's, first of all, next? How do we get bigger in the company? And how do we stop the problems that we're having? Because this magic bullet didn't quite solve all of our problems. And so what we're seeing is that the whole concept of Agile is getting bigger than it used to be, because just the software piece of it isn't enough. It's just a piece of the whole picture. And if all you do is focus on optimizing any piece of a system, including software, well, guess what? The whole system itself will not be optimized. So when I talk about the intersection of design and engineering, I'm talking about thinking bigger than software, and in fact, looking at the whole organization and what are the key things people are trying to do in organizations today. And because of the pace, I mean, we have this enormously rapid pace in our field, called software development or something like that. We tend to sort of lead the world in rapid evolution of whatever the heck it is that we're doing. Whatever was good 3 years ago doesn't seem to be around anymore. And suddenly people are wondering, what's it all about? We better start thinking about much bigger than how to write good unit tests. We've got to figure out how to drive innovation into our organizations and how to use these rapid cycles that we are now able to get to figure out how to beat our competition by being more creative, by having better ideas, instead of letting them have better ideas than we do. So when I talk about the intersection of design and engineering, engineering, we'll call it the kind of engineering we think we do when we're doing software, some more words on that. And I want to talk about 3 kind of areas. One is the elegance of just plain being simple. So the phenomena of simplicity, which you see in a lot of areas, but let's just take Google for an example. This is Google's webpage in 2006. When it first came out in the 1999-2000 time frame, and this was their webpage, every other portal, those of you who remember that? What did all the other portals look like? Just a whole bunch of junk. And this, well, and the idea is I never see this page because it's up in my toolbar. I mean, I never even bother to go there unless there's some nice, interesting doodle there that I'd like to check out. So this is 2006. This is a couple days ago. It actually has changed very little, but its design is, compare them. They have the same amount of information. This one of the interesting things is, besides this black bar, more white space. Now, I'm not a designer. I don't get white space. Right? But look at it. I mean, it looks cool. And part of it is what designers understand. Look at that white space. I mean, it focuses you. And the, see the shadow there? It's gone. And then there's a few lightly colored things down there. Just very simple and very elegant. Now, we don't just see that in Google. We see that in a few things that when we look at it, we say, that is a good design. I like that. Now, I'm the daughter of architects, and so I suppose I should have some design in my blood. Because when I walk into a building that's well designed, I know it. And you do too. And there's an awful lot of buildings that are just built. They're not designed. And there's an awful lot of software that's just built. It's not designed. And there's way too many user interfaces on the web that I can't stand. But let's go on. The next one I want to talk about is experience. So, how many have run into Hipmunk? Okay, so Hipmunk kind of blew me over when I first ran into it. You can't, just see if we can hold that. So this is the Hipmunk chipmunk, and this is an interesting thing because let's just say on October 5th, I want to go from Arlanda in Stockholm, that's the Stockholm airport, to Vilnius, which is actually what I wanted to do last October 5th. And I go in there and I just play Arlanda to Vilnius, October 5th. And it doesn't say, oh, and when do you want to return? It actually knows I only want to go one way. And it gives me these options, and the nice thing about it is if you take a look at this, this is Air Baltic to Riga, and then again, and this is SAS through Copenhagen, and then SAS. You can see the airport you're going in. You can see how long you're going to be in an airport. So here you're going from Stockholm to Tallinn, and then to Riga. You know how close those are? About 150 kilometers. And then here you have a really, really short, maybe 30-minute airport stay. Boy, that's awful tight, except Riga is like 3 gates, so maybe it's okay if your plane isn't late. So you take a look at this, and if you arrange your own transportation and you fly, you can imagine what your trip is going to be like. So instead of those columns and columns of the low cost, because people think you're buying on cost, these guys are selling not the buying experience, but the travel experience. This thing is simulating my flight. I can look at that and I can imagine myself on the airplane, how long I'm on the airplane, in the airports. It's simulating the flying experience. And everybody I know that buys their own airplane tickets, they love this because in one page, it's everything. And in fact, you see this here? This one is sorted by agony. Honest. Actually, this here one is not the lowest price. It's $114. And that one was $92, a little less expensive, but who wants to get up and leave at 8 in the morning, you know, and go through Riga and all that? So the thing about experience is that we are getting used to the few really good experiences that we run into on the web, and we say, that is so good, I just have to tell people about it. And this one has spread pretty much word of mouth because of the fact that the experience of buying airplanes here is just different. And if you're buying your own flight, you say, oh, I like this one. And then there's the magic of stories. So we all know of Pixar. I actually had never seen Toy Story. So I was visiting my daughter last week and I said, gotta watch Toy Story. They said, you're kidding. I said, no, work. It's a requirement for my job. So we sat and watched Toy Story. And here's one of the heroes right here. Okay. So anyway, Pixar is all about telling good stories. They have had phenomenal hits, sort of like Disney used to when it first came out. There's a very interesting article in Harvard Business Review about how Pixar fosters creativity. And the interesting thing is, he says, you have to combine technology and art to get your magic. In fact, Pixar started as a high-tech company doing extremely good computer graphics, added some extremely good designers, and they say that in filmmaking and many other kinds of complex product development, creativity involves a large number of people from different disciplines working effectively together to solve a great number of problems. And that is the problem that we haven't quite solved yet. We've solved having a few people from a few disciplines working together, but we haven't figured out how to get a great number of people from a great large number of different disciplines working effectively together to solve a large number of problems. And so, interestingly enough, at Pixar, the creative folks and the technology folks are paid exactly the same pay scale, which really messed up the creative salaries in Hollywood apparently. But because they have equal importance in the company. You have to have both. You have to have the technology and you have to have the arts. And in fact, they say getting people in different disciplines to treat one another as peers is just as important as getting people within disciplines to treat one another as peers. But it's an awful lot more difficult. It's really hard to get the creative people to respect the technical people. It's really hard to get the technical people to respect the creative people. But you know what? When you want magic, you have to get the people working across those boundaries. And I think maybe that's where we have to go next in software. We have to expand our boundaries beyond software. There's an interesting article. Actually, I think it's also a video by Jeffrey Moore. And he talks about the future of IT for those who are in IT, not in a separate company where you have a product, okay, but where your IT as a function inside of a big company and you're kind of helping to automate that company. And he says, guess what? Until recently, IT was about record keeping, databases, keeping track of transactions and what was going on. And we created a lot of systems of record. In fact, we created so many systems of record that somewhere around the end of last century, people got tired of paying for these systems of record. And now it's been all about how do we do all of this stuff at lower cost? Because, you know, we paved these highways. We don't need any more infrastructure. Then we got to do it all over again just before, you know, for Y2K. So the point is, not that much money is heading towards systems of record anymore. What's going to be next are systems of engagement. It's not a great big ERP system sending me records that have been batched overnight. It's how do I talk with my counterpart down the supply chain over in another company about when that next shipment is coming. Over here in systems of record, where it's been, it was all about transactions. And it's going to end up now being much more all about experience, even in enterprise software. According to Jeffrey Moore, anyway. So if it's all about experience, it's all about experience because at home, people have different experiences than they tend to have when they go to work. And they tend to be very used to, you know, rapid response on the web. And I mean, I have a granddaughter who's 16 years old. She's been on a cell phone for what, 4 years now? Something like that. Now she's 16, when does she head into the workforce? Maximum 6 years after she gets out of college, right? And all her peers are going to be there with her. And think about what they grew up with. They're what you call digital natives. They don't get this, you know, long transactions and batch processing that takes overnight and all that sort of stuff. So it's a point in time where we are not going to be worrying about transactions anymore. We have to figure out how to match the experience that people are getting at home when they go to work. And I'm not sort of making this up. Maybe Jeffrey Moore is making it up. Jeffrey Moore is the guy that wrote the book Crossing the Chasm, the one that says, you know, how you do marketing, but we'll let you investigate that. So this over here favors analytical thinking, which we're supposed to be good at. Analysis, come up with a solution, optimize the solution. But if you're talking about experience, it's much more about design thinking. It's much more about having empathy with the people that are going to have the experience, having imagination as to what might possibly be appropriate, and then iterating towards some sort of conclusion or experience that the people might be able to enjoy. So if this is where enterprise software is heading, imagine where the rest of software is heading. So if we look at an innovative organization, I want to talk about basically these things in design thinking. Empathy, imagination, iteration, those three things down there. And then I want to, maybe if I have time, talk about leadership. And I would like now to say, nobody's asked me any questions yet, so please do. Otherwise, you're going to all fall asleep in the people. So please ask questions anytime that you want me to, you know, go some right path or something like that. Feel free. So let's talk about this concept of empathy. If you look at Pixar, again, how they work, one of the things that they do to have a creative environment is, first of all, they empower the people who are creative to do the leadership. They don't have marketing people say, here's the next good movie. They let the people who have good ideas, in fact, their development organization doesn't decide on the movies. Its job is to form small cross-functional teams of people to think up new creative ideas and make sure those teams work well together. And so if you have a good idea and you have a mediocre team, they're going to screw it up, right? And if you have a mediocre idea and a great team, they're either going to fix it up or they're going to come up with a better idea. So you really want to have creative people that are good. And the second thing is you want a pure culture. That means that everybody is willing to take wherever they are, whether it's part way done or not, and show it to other people and get feedback. Even if the feedback is, that's not very good, you have to improve it. So they do an awful lot of showing each other partially done work. And remember, it's not just creative people or just technical people. It's the combination of all the people needed to make a movie with a lot of peers trying to help each other do their best work. So everybody is invested in helping everybody else turn out their best work. And they try to create a very much of a learning environment. Now, if you know anything about Pixar, you know that it wouldn't be here if it weren't for Steve Jobs, who happened to buy them from Lucas and set them up as a separate company. And he really had a ball being CEO of Pixar. In fact, that almost kept him from going back to become re-becoming CEO of Apple. But he did. He went back to Apple, and he brought that same concept. He brought the concept that it is a balance between peers who are really good in technology and who are really good in creativity, working together. Do we do that? Not enough. So here's the product manager for the iPhone and iPad. Strauss, Greg, okay, I can't say it. John Wiss, do I say that? Okay. And he basically says that Apple is world class in designing, and it's also world class in software development. And because they're world class in both, and because they develop all products with both their software and their design working hand in hand together, is why they come up with brilliant products. So the idea is that whenever you design a product, we try to take advantage of the engineering capability and the design capability at the same time in the same team. And I think we got to think really hard about how can we do more of this? How can we make sure that we have both designers and technical people designing at the same time the same product? So the intersection of design and engineering. Both of these companies claim that their brilliant performance is due to the fact that they have people that are both designers and technical people working hand in hand together all of the time, thinking together, creating together, bouncing ideas off of each other, and so on. So here's design. Design, and I don't mean software design, right? And I don't even mean UI design. I mean product design. I mean when I walk into a building, I can tell if it's been designed by an architect. Okay, that sort of thing. Engineering, good technical practices. And then I'm going to put a third one, which is empathy. That is, we have really good people in design, really good people in engineering, technical area, and people who really, really, truly understand the customer or consumer problem that we are attacking. And it's there that these companies get innovation. So the question is, how do we create this circle in our development practices so that we get this innovation here? How do we get all three of these working together? It's probably not taking a book about how you do Agile and following the rules. It misses too much. So empathy. Empathy always starts with multiple people with different backgrounds. When you do design thinking, the first thing you make sure of is that your team is composed of people who do not think alike. The groupthink concept is not what you want. You don't want all software folks, you don't want all technical people, you don't want all designers, you don't want all people from the same country. You don't want everybody alike. You want people with different backgrounds that are going to bounce, that are going to respect each other, treat each other as peers, and bounce ideas against each other. And then you have some sort of problem, some sort of market problem, and you want this team of people with different backgrounds to go and understand that problem. Really think about it, really evaluate it, really examine it. And then they come back and they talk to each other and they draw, say, a journey map. What did we see this customer going through? What kinds of problems were they having? What issues occurred as we were watching that particular event that was happening there in the customer? So if they're going to, for example, design a check-in, check-out thing for an iPhone, they really want to know what's going on here. And so they talk about it and they create a discussion of what is it that we saw? What do we need to know? How does that customer go through their life and go through their problems, and what problems do they have? Empathy means we have a lot of people with different backgrounds understanding the real problem. So we are talking here about a whole team. We are not talking about this. Somebody going out to the market and bringing back a prioritized list of features. You ever heard of that term? Prioritized list of features and giving them to a team to develop. I'm sorry, but that's like good idea 8 years ago, maybe even 5, but that's not what's going to get us into the future. We need to be much more creative than that. At minimum, we want to make sure that the leader is bringing the team to really understand the problem, is having a discussion so that you can come up with some sort of a really creative solution. So, and thinking about what is this solution that we're heading for. Now, back when we started Agile, there was this massive fear that if we spent too much time thinking, we were going to be doing big design up front. Ever hear that fear? Well, you know, zero design up front is maybe not enough. So let's figure out how we can stop doing this, if that's what we happen to be doing, and do quite a bit more. Let's have our diverse team. Now turns out there's a few more people on this team than there used to be. Not just developers and testers. But if you're going to have design, where are designers? And surely you need user interaction designers, but maybe you need product designers. Maybe you need somebody to think about where's our architecture going to go. So you need to be creative, figure out where you're heading, and have a solution that you're looking at the same time as you are at least having a good discussion across the team of where you're going. Now, this doesn't mean you have to have all of the things solved at once. I'll talk more about that. But it does mean that you have a truly cross-functional team. This is a quote from Scott Cook. Scott Cook was the founder of Intuit. It's a big financial services company now. I don't know how good it is in Canada, because it's sort of geared around U.S. financial stuff, but you have much Intuit products around here? Okay. And after he was CEO for a decade or so, he got tired of being CEO and got somebody else to be CEO. He said that was kind of hard, but he knew he wasn't the best CEO. And he spent the time since, maybe the last 6 or 8 years, studying about, he went back to Harvard, where he's from, and then he did some research with Clayton Christian and others. And then he went back to his company because he wants to figure out how you can keep great big companies from getting old. You know, big company disease or something like that. So he's got a big company. How do I keep my big company new and young and innovative? And he studied companies that were able to do that. He didn't find that many of them, but he said only a few companies have been able to sustain growth over time by coming up with successful new disruptive businesses decade after decade after decade. Now, one of the companies he studied is my company 3M, which at least until about the time I left in '98, was very good at that whole concept of constantly coming up with new innovations, decade after decade after decade. And he studied other companies. And what he found, and it certainly rang true to me, is the companies share a common practice, the ones that manage to do that. They have systems in place. They have systems in place. It's not random. There are systems in place that encourage small cross-functional employee teams to conduct frugal experiments, just plain to try things. And so he set about creating small cross-functional teams at Intuit and allowing them to conduct frugal experiments, to just try experiments and see, as long as in the financial services area, see if their experiment might be creative. And I think you're going to see a bunch of more new novel things coming out of Intuit. Another company that's been doing a lot in this, a big company, massive company that's been doing a lot of new and interesting stuff, is GE Healthcare. They went and decided that they should be looking at China and India for the next medical needs, not Western countries, not Europe, not North America. And they set up a team in China which invented a very low-cost ultrasound machine, which actually now you find in hospitals all over here, but it was invented in China. And in India, an extremely low-cost EKG machine, because in India you have the highest incidence of heart rate in the world. And they're beginning to have a lot of inventions in countries like that, which are then coming in as very disruptive technologies for the US. So you take a look there and you'll find amazing number of new innovative products too. But not that many big companies are able to do that. And they have these teams that try things. They don't have to be successful. They have to conduct inexpensive experiments so that they can quickly decide if their idea is any good. I mean, you've heard of this idea in Agile, hey, if we try some spikes, maybe we'll see if it works. Well, this is a product spike instead. Organize, now this is from Jeffrey Moore again, and Jeffrey Moore did write the book Escape Velocity. It's sort of his capstone after 5 books about marketing. And he said, when you want growth, when you want disruptive growth inside of your company, then you should organize your growth initiatives into standalone, vertically integrated, independent business teams led by an empowered entrepreneurial leader similar to a startup company. If you want your growth initiatives to survive, if you park them inside of an ordinary business, the ordinary business will not have the incentives. It'll consume the new startup concept. And here's somebody else, Werner Vogels from Amazon. Okay, so he was behind a large amount of the web services, things like that. Amazon is one of the few companies in the world where the IT organization became a profit center and started driving huge amount of revenues in the business. Wouldn't that be nice if your company's IT department started bringing in a lot of money? But anyway, he said innovation comes from small teams that work directly with customers. Directly with customers. So all of these are talking about not somebody tell a software team what to do, but having teams that include multiple skills, and for sure including some software, because that's usually, sort of there, and have that team get in touch with real live customers out there, figure out what their problems are, empathize with them, create experiments, try things out, and have, not every time, but a good amount of time, have some disruptive inventions that come out of it. It's like a broken record. Everybody who talks about how do you get innovation in company talks about small cross-functional teams that actually are like little startup businesses inside of the big business. And so I'm thinking, maybe this is a better idea about how to organize our teams. Yeah?
An observation here, I believe at Amazon they have something about the 2 pizza boxes team.
Yep.
So they kind of walk the walk of basically when you get too fat, too big, you speed it up and work like a startup.
Yes. There's 2 things about Amazon that intrigue me. You've heard of Conway's Law? So Conway's Law says that the structure of your architecture and the structure of your organization tend to match. So if you think about the 2 pizza teams at Amazon and the service, a service and a team are a one-to-one relationship. They have services that in the end, and it took them 9 years to get there, are sort of a mini internet inside of their company. So every team can do its own little thing. And the other thing is, Vogel says in this same interview, that teams don't just do things, they have to create a proposal. And do you know what their proposal looks like? Their proposal, a team at Amazon that wants to try something, they have to write a press release for their new product. And if the press release sounds good, if they can actually write a good press release, then they can use that to get approval to proceed with their new product. So they have to really understand what they're proposing to do is going to do for customers. Otherwise, it's not something that they get to do. So this is empathy. How do we create whole teams that really care about the customer problem? And then where do we get imagination from? So here's another model here. So Fred Brooks, you know Fred Brooks. He wrote The Mythical Man Month, the classic in software engineering about the IBM 360 operating system. Yeah, back when software was written in assembly language, and he was the head of that effort at IBM. And he wrote The Mythical Man Month, which, you know, back when we didn't type to write, you actually had to write on paper, or maybe type at a typewriter. Imagine that. So he wrote The Mythical Man Month, and it became a very popular classic. It was republished 25 years later, which was approximately 10 years ago, so that's maybe 35 years ago that he wrote it. And just recently, about 2 years ago, he came out with a book, The Design of Design. It's a bunch of his essays talking about the whole area of design. And because we're looking for imagination, let's think what is really part of design. The first thing he says is, when designing a solution to a problem, you have to understand the problem. The people who are involved in the solution need to understand the problem. And by the way, deciding what to design is the hardest part of the task. It's not something that some other department can come and tell you what to do. Deciding what to design is the hardest part. It's where the cross-functional team needs to get in touch with customers to understand the problem, to get empathy. A small team is much better than an individual in figuring out what is the real problem, what should we be designing. The second step is when you're designing a solution, designing isn't just to satisfy requirements, whatever those are, but it's to uncover requirements. It's to uncover what the real issues are. Design isn't simply selecting from alternatives, it's realizing that the alternatives exist. So where are we doing this? Figuring out what should we be thinking about. And when implementation, this is a kind of a damning statement, he says, that one of the most striking 20th century developments in the design disciplines is the progressive divorce of designer from both the implementer and the user. As a result, instances of disastrous, costly, or embarrassing miscommunication abound. We have taken design and somehow thrown it out to some other planet and said, bring me your design and we'll implement it. We can do better in software. We need to be involved in this whole process of design, not just have somebody hand us the results of their design. And part of the reason is because you have to iterate here and sometimes all the way back to understanding the problem in order to have a really good solution. Design and implementation need to be tightly integrated in order to get the innovative designs that we need to have. So we have this concept of specialization. And specialization is, I think, maybe this is the biggest problem we've had. We have separated design from implementation. The essence of design, of course, anybody here study design? Anybody study design? Okay. So when you study design, you learn that you don't try just one thing, right? You always try multiple things. Am I right? Or am I didn't study design, actually. But I've been told. Because you want to have an array of solutions which you iterate on and figure out which one is best. For sure, you understand that if you head down a path in design, it's bound to be the wrong path if it's your first option. You need to look at various options. And you choose amongst different alternatives, and then you approve it, obtain funding, that sort of thing. Even if you're designing an ad campaign for marketing. If you're a design studio, you'd be fired if you brought only one marketing campaign to a company, because design is having multiple solutions. But then when we get to development, we think about implementation. Well, okay, now we've funneled it all down, we've got a single design, break it up into little pieces, estimate how long it's going to take, do each one, put them together into a package, and we're done, right? So we've got all of this iteration going on, and then bang, a single solution, and then quickly we implement it, and uh-oh, not quite right, and we have to go up to the top again. So there's got to be a better way. We need to integrate implementation in with design. And what you're seeing in the companies that have these very rapid development cycles is they're not distinguishing between these two. It's something that goes all the way through from being creative all the way through to trying something all in one cycle, not in a let's have an idea and then implement it as a two-step process. So this is a very interesting article because I've been thinking about what is engineering all about? Because, you know, I actually was an engineer. I didn't get an engineering degree, so I don't know if you could call me an engineer. But when I was working in process control, my title was engineer. I even signed drawings. And when we did engineering, we didn't think about just the design of the solution. We thought about understanding the whole problem. So if you take a look at engineering, you start with problems, you understand them, you figure out what they really need, you see if there's alternative solutions, you build some prototypes, you try, you redesign, you iterate, and then finally you get to some sort of a result. So when I designed process control systems, I didn't have somebody give me like a long laundry list of requirements. There was no such thing. In fact, I'll show you how long my requirements were. And we were expected to engineer the solution. Now, actually, that's not much different than the scientific method. Try a few things, create a hypothesis, do some experiments, test your hypothesis. All of this is understanding the whole problem and trying experiments towards getting towards a solution, or trying prototypes towards getting towards a solution. So think of engineer as a verb, not a noun. To engineer a solution. So here I am, and I did an awful lot of software development for about 20 years or something like that. And I never saw detailed specifications, never had long lists of stories, never had stories actually. And actually we were quite able to do very good software development without all of that stuff. So let me just give you an example of a process control system. Say it's going to go, when I went into the Oklahoma City plant. It's a brand new plant, brand new addition onto a plant. It's going to have a new coder, and we were to design the process control portion. And here's our requirements. It had to make good product. It had to be on time, because when you put in a new plant and it's ready for startup, if your process control system isn't there, that's really expensive. So, it wasn't me, it was my boss who'd probably lose his job if we didn't meet the deadline. And by the way, they were always on time. That wasn't a discussable topic. The operators had to find it convenient to use, because we were told, in a manufacturing plant, operators make product. You put in a system, they don't like it, they will defeat it, because they will make product. They defeat it, guess what? It's your fault, because you didn't take them into account. So they better find it easy to use. It will be maintained by the plant engineer. That went without saying. Plant engineer, very capable person. This was when software was kind of new. I figured a plant engineer could do basic, so that pretty much determined the language. It should contain the latest technology. We always wanted to be using the latest technology. That's it. Those are my requirements. I had approximately a year, and that meant starting up in the plant. So I had to ship in 9 months. I had 3 months to order, 6 months to work on it with the team, 3 months to ship, install, and get it running. And that's it. Those were the only things that I had as requirements. Everything else that we might have had would be a specification, but not a requirement. Everything else we got to decide. And we had a team of about 3-4 of us. When doing a programmable logic controller, and I did the software on the analog part and mostly the analog controls. And then upstairs were the people that were designing the process, so we had to talk to them to see how many points we wanted to control and stuff like that. And that's enough requirements. That's all you need, because when you're engineering a solution to a problem, the one who writes the detailed specifications is the one who's designing the system. Those detailed specs, those stories, you know what they are? They're design. and they're designing the solution to the problem. Now, who should be designing the solution? Who should be engineering the solution to a problem? If it's a technical problem, then a technical person should be engineering the solution. We don't want to have somebody from, I don't know, let's say marketing, engineering our solutions for us. We want to engineer our own solutions. So we want to figure out how to create a team, go back to that, which has the people on it that can understand the technical problem at a high level and come up with the technical solutions rather than somebody handing them the solution. Now, I couldn't understand everything about a process control system, but I was working with senior engineers, with the guys who were designing the process upstairs, and as a group, we were quite capable of putting a large-scale system together without a whole bunch of specifications. It was inside of one company, so we didn't worry about all of the, what happens across firms. But we just didn't deal with detailed specifications. It wasn't a concept, because how could we get the latest technology if we had to design it a year in advance? That didn't cut it, even back then when technology was moving slower than it is now. So think about, how are we allowing our technical people on our teams to engineer solutions to the problems that are being presented? Or who are we having engineer? Those people who write those stories, those people who write those specs, those are the guys that are engineering the solution. Are they capable of that? Is that their background? Have they studied how to engineer solutions to technical problems? Or isn't that what we are supposed to be doing? Back when I did software, it was what software engineers did. We didn't just write code. We engineered solutions to problems. So I think our teams need to be a little bit bigger. I think we need to understand that we need to create the solution and execute it, and have within that team the people who understand the customers, the problem, the technology, design, and that makes our teams a little bit bigger than just developers and testers. Or a few other people like that, and maybe one UI guy. We need to think about the kind of team that we would have if we were a startup company or a cross-functional team in a larger company. So how do we make those kinds of large teams work? I mean, doesn't Agile say a team is like maybe 7? Maybe plus or minus 2? You can't fit all the people you need to do a sophisticated product into 7 people. Maybe to do a service at Amazon, but typically you can't. So what do you do? Well, this is not a new problem. This is a problem that people who have been doing hardware and hardware with embedded software have been grappling with for, I don't know, since long before I was doing software. And it kind of works like this. A team is all of the people you need to put the product or the process control system on the market. It's not just developers and testers with somebody telling them what to do. So here is an example. This is actually, Tandberg is now part of Cisco, and but this was back when they were Tandberg, and this is an Oslo company. And back in 2007, see, these guys do video conferencing, very, very high-end video conferencing. And Cisco bought them, and now Cisco does. Well, even then it did very high-end video conferencing. And they decided that what they really needed was a very, very, very high-speed video multiplexer to take all of their cameras and video speeds and very high-speed multiplexer. And they had an idea, and 20 months later this thing was on the market. Now, anybody who's done any embedded software, even including ASIC chips and stuff like that, that is a really fast schedule. They had about 60 people on this team. They told me that the ideal team size is somewhere between 35 and 70 people. And that rang true. Because when we did product development at 3M, our team sizes were somewhere between, say, 20 and 50 people. So they said 35 and 70 people. That's how many people it takes to put a whole product on the market. Here's the kind of different functions they had. If you notice, 2 to 3 people in mechanics, 4 to 5 in electrical, 40 to 50 in software development. So that's a lot of software development. That's not 7. 5 to 6 people with firmware, 4 test people, 1 approval. They had a project manager. And the project manager spent an afternoon telling Tom and me how he did it. And basically, And this, by the way, is a pretty classic way of doing this. You manage the project, he managed the project like mini projects, with every mini project about 3 months long, and every mini project ending in what I'll call a synchronization point or an integration point, but what he called a prototype. So he had prototypes, and he said the D1 prototype used existing hardware because it was too soon to have new hardware, and a few new chips, and it did a certain amount of stuff. Now what you've got here is different sub-teams, but they don't call themselves a team. They're a team for the Codec C90. This is the Codec C90 team. This team does one thing, this team focuses on something else, this team focuses on something else. Lots of cross communication. And here, there's a D1 prototype. Everybody gets together, what have they learned, and then they go on. For the D2 prototype, they have several new hardware parts and quite a bit of new software. And they all get together and they synchronize on that deadline. So the project manager is getting everybody to sync every 3 months, put their stuff together, see where they're at. Come time for the D3 prototype, and something happened. What happened was that they discovered there was a new chipset on the market which was much faster than the old chipset. And they all got together for the D3 prototype and they looked at each other and they said, we gotta have that new chipset. Just gotta have that new chipset in here. It would be crazy not to have the new chipset. And so the project manager says, okay, you got a day, tell me what's gonna take. So they all thought about it and calculated it and they said 2 months. And he said, okay, next prototype is in 5 months instead of 3. And come out with a D4 prototype in 5 months, and they had the new chipset in there, which is fast because then they had a product 3 months after that. Chipsets with a product in less than a year is like, they were 2 years ahead of their competition at this point in time. Because the whole group took a look and figured out what do we all need to do to get that new chipset on the market and get it out here. Because they looked at themselves as a whole team and a team that communicated across the sub-teams and synchronized on these points, that's how they got this synchronization and the new chipset in 2 months added to the overall schedule. Project manager said, well, you know, you kind of like to keep to a schedule, but events conspire in the world to change the way it works, and we have to be able to rapidly change to meet what the world comes up with to throw at us. Yeah?
Assume that the architect of the software was sort of partitioned in a way where the teams could sort of focus on those pieces that they could. Is that perhaps how that might work?
I don't know. I know that they did have a fairly modular design for this whole thing because they then spun out multiple products off of it. But I do know that they worked together very well as a fairly large team. But they worked on these sync deadlines, and then they did, I think, do some amount of small teams. It would be easier for me to actually introduce the guy that could answer that question and tell you the answer. But there was nothing sacred about 7, I can tell you that for sure.
Because the way I sort of thought about it in my mind is that if you had individual teams that are 7 to 10 in size, and they could somehow collaborate through, you're saying these sync points, but if they could collaborate where the architecture supported how they organize themselves.
Well, yeah, that's what actually happens at Amazon. They have services that are truly distinct, and a group of 2 pizza team, 7 to 10 people, manages a service with contracts on the edges of it. They didn't do that in this quite so much. I'll tell you what research says about 7 people. Research says that when you have a group of people in a room, if you have more than approximately 7, it will break down into more than one conversation. Okay? That's what research says about the number 7. So if you want if one conversation is essential, then the team had better not be more than 7. But there's nothing about this product that means that at all times we should have one conversation. Yeah?
So are the people in the sub-teams moving teams during iterations, or are they staying in the
Okay,
same
let me tell you about when I did process control systems, because I know that much better.
Okay.
When I did process control systems, my sub-team was in the process control department. We reported to somebody who was a very, very good process control engineer in his own right. We had colleagues who did process control systems. We had people upstairs that were designing the processes. There were approximately 15 or so in a group up there designing different processes. I'm not quite sure how they were organized, but what I did know was we would go talk to them, we get the drawings, and we just count the points that we had to control. How many motors, how many, dancer arms, how many temperatures, how many pressures, that sort of thing. And then that would tell us what we needed to do with our process control system, because all we needed to do was to control that many points. So the interface with the people was constant, but it was pretty well defined, the interface between a process and its control. And I assume that they did a certain amount of that in this too, because they were able, as modular it was, to spin off other parts right away. But it's not that and we say, well, if we have 5 teams of 7, how do they coordinate? If we stop thinking of them as 5 teams of 7 and think of them as a product team, which, by the way, works in some sub-teams and syncs on a very regular basis with each other with a real live prototype, hopefully, that's the way this kind of stuff has been done for decades. There's nothing actually very new or novel about this approach. This has been being done in embedded software systems and hardware systems for many years. And companies that have done that think of this as a natural process, especially with these syncs. When Toyota does a car, it has a sync approximately every 3 months for 2 years. And it's that synchronization where all the sub-teams sync with each other that causes the most of the communication. In the meantime, the teams working on the subsystems are responsible to go to the other teams and get all the information they need. And the project manager here, the chief engineer at Toyota, job is to be talking to everybody and see if any information's falling on the floor or it needs to be swept up and handed to somebody else. But you get a lot of that happening at the synchronous. Now you can do, 2-week iterations and stuff in here if you're in software, but if you're doing hardware, 2-week iterations, you'll tell everybody it's crazy, so don't, because it probably is hard. So it's these integrating events that create a cadence, and you actually decide, knowing what the next integrating event is, what you're going to do in those 3 months. So we can work with large teams. Large teams do work, and large teams engineer whole solutions, complete products, not do what somebody else has told them to do. So this concept of iteration is one of the key reasons why we really need whole teams. So this is, for example, Post-it notes. Good 3M product. It was being invented, and I mean being invented, for about the first 10 years when I was at 3M. This did not spring up overnight. I worked after some years for the guy who was the technical manager of the division that invented it, and he told me lots of stories. But the thing that we learned at that point is we could do, by the way, frugal experiments. Didn't take a lot of money to put new products out and test them, by the way. You could do it pretty cheaply. And so our mantra, everybody was taught, was you make a little, you sell a little, you learn a little, and you do it again. And that's how new products happen all the time. And that concept, we had, if you needed it, you could get 15% time, which I think Google stole a little bit of. And you could try things, conduct frugal experiments. This was experiment, the brightness enhancement films with microstructured surfaces. Lots and lots of novel products came from that in about the mid to late 1990s. So about 85 years after the company was founded, still dramatic breakthroughs because lots of small teams were doing this. Make a little, sell a little, learn a little. Now, those were whole teams, little tiny business teams. They were not somebody from marketing telling some people in lab what to do. So it's this concept of at a whole market level, you need to figure out what you're trying to do, build some, measure the results, learn, and go around this loop. And by the way, the company that gets around this loop fastest is going to be the winner. George Stock wrote this interesting book, and Competing Against Time. It's almost a decade old. Actually, it was in the early 90s. It's almost 20 years old. And he said, in industry after industry, companies with faster innovation cycles have been able to move from follower positions to leader positions in about a decade. And here's the most interesting. Small, experienced, dedicated, decision-empowered teams allow fast innovators to introduce 4 times more product, the same amount of time, with the same number of people. That's productivity. And when he finds companies that introduce large numbers of new products, this is where it's coming from. Small, experienced, dedicated, decision-empowered teams, which gets back to that broken record of small, cross-functional teams that can try rapidly running through experiments. And when you get those teams creating experiments and figuring out what works and what doesn't and iterating towards this circle faster than the competitors, you get companies that can catch up if they're in a follower position, or companies that can introduce way more product if they're in a leader position. So this concept is what Eric Ries was talking about, when he talks about lean startup. I know Eric was up here once, and how many have heard of lean startup? Okay, so you get the general concept, and it's how fast can we get around this loop. The most interesting thing in his book, Lean Startup, that really, really hit me between the eyes was he went to a company, Grocket, and he said they were doing absolutely the perfect Agile environment. All the rules they were following, they were extremely disciplined. They had all sorts of automated testing, and they were just really, really, from an engineering perspective, from a process perspective, very, very disciplined. But their company was only doing so-so. They were doing software to help people prepare for college testing, like tests that you would take to get into college. They thought it would be popular, and it was doing not so well. So he asked the president, "How do you know you're doing the right features?" And he said, I guess. And then he went to the development team, this really great development team, and he said, "How do you guys know you're doing the right features?" And they said, "It's not our problem." Now, I'm sorry, but that's the wrong answer. We've got to get our teams not saying it's not our problem that we may or may not be doing the right features. It's got to be our problem that we're doing the right features. If that's, highly disciplined, perfect Agile, I don't want to be there. I want to have the development team say, "Good question. Let me think about that at minimum." But certainly not, it's not our problem. That's the product manager's problem, product owner's problem. It happens to be, our CEO, so it's his problem. That doesn't allow the team to enjoy engagement in the whole business and its success. So think about A/B experiments. This is kind of what Eric is talking about. He says, you know what? If you could just take every feature and run an experiment and see if it's any good, you could put the feature in or take it out depending upon how actual real-life people respond to it. So an A/B experiment, you take your visitors and you divide them into group A and group B, and you present them with something. Like here, for example, this is an extremely simple example. Watch the tour or sign up now. Watch the tour or sign up now. See that? What does it say? Anybody read it?
It's free.
It's free. Okay. Now, which one is going to get more clicks? Is it going to really matter? This one got 14.5%, and this one got 18.6%, so it really matters. And the concept here is that you don't really know by guessing which kind of thing is going to cause people to do what you want them to do on your website. Here is an example at Amazon. This was a guy named Greg Lindland, and he created a prototype that when somebody put something in their shopping cart, they would get this little thing down at the bottom saying, "People that bought this also bought these other things." Have you ever seen that? Yeah, well, he tried that out. And the vice president of marketing discovered that he was doing it. And he said, "Greg, there is something you do not understand about sales. When somebody puts something in their shopping cart, you do not bother them. You do not distract them with other information about other products. This is absolutely not acceptable. Don't even think about it. Stop all your experiments. I don't want to hear about it anymore." Okay, senior vice president. Of course, Greg, being a good free spirit, decided to put together a test anyway. without telling for sure the marketing guy. But in the end, he needed his approval to actually run the experiment. And because at Amazon they believe a lot in data, and he had done all the work kind of on the side to put the test together, he got to run his test, although the marketing vice president was extremely annoyed at him. Until, of course, the results came back and it showed that they routinely got 3% increase in sales every single time that they did this. So now they have 3% increase in sales. And if you want to read more about it, there's a link here. I'll make sure you can get these slides if you're looking for any of the links. So just because the vice president of marketing says no doesn't mean that the vice president is right. Yes?
I just had on the topic of A/B testing, so I've read the lean startup and a lot of the examples you use for A/B testing.
Yeah.
And a number of articles that have been published recently on A/B testing. And the thing that seems to come up quite often is that, based on this information that's become quite popular, people are taking a relatively simplistic version of A/B testing where you may be looking at 14.5 versus 18.6, but you don't, there's no actual understanding of statistics being applied to the A/B testing that's being done.
Okay, so I just happen to want to address that in the next part of the slide.
Okay.
But this is not simplistic, okay?
If you can
No.
please repeat the questions, because...
Oh, I'm sorry. He's worried, and rightly so, that if you just randomly do A/B testing in a simplistic manner, you're going to get simplistic results. Fair enough? And that's absolutely true. So one of the more interesting studies about doing this kind of testing is from KDD, that's Knowledge, Discovery and Data or something like that. And this is a Microsoft paper. And what they did at Microsoft was that they did tests that were statistically valid to check whether or not people in product development and marketing made the correct guesses about what to put in products. Okay? And what they discovered, and it's reported in this paper, is first and foremost, the guesses about how customers are going to behave were wrong more often than they were right, even if it was the expert person whose job it was to know. So you can assume, at least based on these results, that who's ever guessing at what should be in the product is going to be wrong more than 50% of the time. That's what they found with these experiments. Secondly, forget arguing about it. Just run tests, but make sure they're statistically valid tests. Don't worry about the perfect design. Start doing some testing with in-depth analysis testing, and you'll get better answers than if you create the perfect design. But you have to test often. Most experiments are not going to tell you much of anything. And the only real failure is a badly designed experiment. If you're going to do this kind of experimenting, you have to understand statistics, and you have to understand how to design valid experiments, or you're going to, as you said, get an awful lot of simplistic answers that aren't going to tell you very much of anything. For getting a better user interface, okay, simple stuff. But for having something in depth like putting a whole new feature in Amazon when you put something in your shopping cart, do I actually show people who did this also did that? You need a very sophisticated set of experiments in order to prove that that's valid. So I'm not going to say a whole lot more about this, except for the fact that trying stuff and testing it, going around a learning loop, a valid learning loop, has become the way companies today figure out what to put into products. And when you do that, again, you need a whole team involved. This is not something that is just in one department called, I don't care what, marketing or product management or something like that. You need an entire team coming up with this way to run through this learning loop and learn what it is that's going to work. There are many ways to go through this loop, not just this kind of testing, but because it's so easy for us to create data, and there's a lot of knowledge about how to do it well, it would be well for us to incorporate this whole concept of testing the whole idea of whether or not something's a good idea as part of the development process. So when Eric talks about in the Lean Startup, he talks about the fact that we should use as metrics stuff that really shows cause and effect. Not just how many visits you get on a website, but if I do this, if I make this change, do I get 3% more sales? So you really need to create cause and effect chains. And when you want to do that, you want to understand what is it that drives my business. So for example, when we were doing product development at 3M, we knew for sure what Jim Collins calls economic denominator was. Our economic denominator at 3M was always margin per unit, margins per sale. The amount of profit before taxes that we made on any sale, and what percentage of the selling price it was. And as long as that was good, we didn't care about anything else. We didn't care about revenue, we didn't care about size of product, nothing. Just on any individual product, we were looking at margins, and as long as that was good, we could do just about nothing wrong. Now that was just because of the unique situation we were in. So what you're looking for is, what is that economic denominator that you want to drive? Or maybe it's your net promoter score. How many know what a net promoter score is? It's a really good single way of understanding whether or not customers are satisfied. So you find out if people think highly of you or not by asking, would you recommend my product to a colleague or a friend? And if they are very, very enthusiastic, they absolutely would. Otherwise, maybe they're skeptical. So that's how you get a net promoter score. Read about it if you're interested. Or if it's a new startup, trial rates or conversion rates. And what you want to do is figure out, when you're adding features, do they change your economic denominator or not? Do they change your economic model in the right way, or are they just sort of interesting features? Because if you don't have a way of measuring cause and effect, if I make this change, do I change my economic driver, then you may be wasting an entire large amount of time doing an awful lot of stuff that's not useful. I've heard so many times, marketing thinks if we just have more features, we will sell more product. You ever hear that? Okay, how do you know it's true? Well, you can be sure that half of them will not. If Microsoft is right, that half of the features experts want are worthless. If you could just stop putting in those features that weren't going to make any difference, think of how much productivity increase you could have. And we really, really have a problem in software of putting too much junk in our code, not having it simple, not having it elegant, not having it well designed. Just let's throw in a lot of stuff. I always call that lazy marketing. We got to get way beyond that into figuring out what is really going to cause our economics to go the right way. C, it's already 20 to 8, so go ahead.
You mentioned that you want to improve things that can be measured. What about things that are hard to measure? Do they just not get validated? Do you end up in an adjustment?
Well, that's why you have to have both design as well as, how can you prove that a simple, elegant homepage like Google's was going to drive a lot more people than, colleague like Yahoo or whatever?
One of the designers who left Google said, I was in meetings where I was asked to prove that a 4-pixel line is better than a 5-pixel line.
Well, I actually don't think that they do that at Pixar. Think about it.
It was a Google.
Yeah, I understand. Where you see really, really good design paired with really, really good technology, you have creative designers who are expected to be good, who understand how to talk to each other about good design, having arguments with each other, and the technical people engaging in how to support and deal with that from a technical part. And as I said, since I come from a family of architects, there's no way to prove, but I can tell just by looking at a building what is good design and what isn't. And you can tell that too. There is such a thing as good design and not. I'm not a designer, but I sure can tell where it's there. And if you've got to prove it, every last piece of, that's why I tried to show you different pieces of this puzzle. There's more than one piece of the puzzle. There is iteration, but there's also imagination. There's also great design. There is also real true customer understanding. And you can't just have one of these and drive it all the way out to there and leave the other ones in the dust. You have to have a combination of all of those things. You have to have design, you have to have engineering, you have to have empathy. You have to have all three of those. And when you can put all three of them together is when you're going to get something brilliant, I think. So It's not just about data, but there's a lot that can be done with data. It's not just about design, but there's a lot that can be done with design. When you can put the two of them together and add true empathy for the customer, it's that spot right here, I think. When you get all three of them here, that you get something that's going to be brilliant. And how do you do it? I think you have to have a team that works well together, that on a pure basis, that has brilliant designers, brilliant engineers, and people who really, really have empathy with the customers, and also know how to work together as a group and appreciate each other. It's not easy to put that group together, but there's a lot of startup companies that have been successful at that. Maybe not a lot, but there's a good number. And when you see stuff that's really, really cool, that, I don't know, how many here use Dropbox? That's a lot. I think, what do you think, 90%? It's 18 months old? I don't know. How did they do that? How did they get this many people? And I tell you, all over the world, I ask the same question. Numbers are almost the same. How did they get people all over the world to be using their thing in 18 months? There's as much really, really good design in that as there is good technology. There's brilliant design behind it. So, and they didn't try to prove. You know what they did, Dropbox, to prove that that was a good idea? They needed funding, and so they created a video, and they told their funders that at the end of the video, anybody who watched it who thought it was cool could sign up for the first release, and maybe they get 5,000 or 10,000 over the weekend. And within 48 hours, they had 75,000 people signing up from seeing that video that went viral. And that's how they knew they had a product. And it wasn't until 18 months later that they released it. Why? Because they said it has to work perfectly from the first day or our company will crash. They were not trying to lots of iterations towards small little steps because they knew that it would fail. They had to have every operating system and every device and everyone working flawlessly before they thought about releasing it. So, so it's not all about small increments. It's not all about just the technology part. It's about the whole package somehow balanced in a way that makes sense for what you're trying to do. Yeah.
How does work teams to work with each other as peers? Small cultures are rare.
Well, for one thing,
Repeat the question.
oh, excuse me, thank you. How do you get teams with different backgrounds to work well together?
As peers.
As peers. That's good. As peers. One part of it is, the status inside of the company. It comes down to pay. Are people paid the same? It comes down to whether or not people would look at the work of the other function and consider it valuable. So there's a lot of, I'm an engineer, those guys are just, drawing. I'm a designer, those guys are just write code. So you have to have a way for at least a group of people to understand that as a group they live or die together. And in a large company, the very first thing you have to do is look at your culture and your habits and the way you pay people. Because all of those things will cause people to behave strangely. In the article on Pixar, he said it was really a radical concept that creative people and software people would be paid the same amount. It was unheard of. But there just was no other option because they otherwise would not treat each other as peers. It's the hardest thing when people don't understand that other area and what it takes to make it work. So I think working together in small teams helps a lot because I know we always had small product teams in 3M, which included every single function in the business. So if I was working on a team, I had people at my approximate same level in manufacturing, in QA, in every other function on my team. Even the lawyer was on my team. Even a financial guy was on my team. And we got to respect those functions for what they did because at our level, all of the people from those different functions work together to put a new product on the market. I don't know if that helps or not. You had a
Sorry,
question.
did they raise one group's salary or lower the others?
Oh, did they raise one group's salary or lower the others? They raised the salary of the creative people quite a bit and changed the whole pay structure of creative people in Hollywood while they were at it.
I think it's more than that, like even the creative people, technical people, you have the QA being paid less than the engineers.
Yeah, so why would QA be paid less than engineers? Where does that come from? A whole different understanding of what QA is than what I have. Yeah?
I think it's really about where you hit the nail on the head where you said the team has to live and die together. It comes down to accountability because if the manager who throws finger up in the air and chooses a feature, hands down to development, well, he's ultimately accountable for the failure or success of that feature and not the development team. That's why the development team doesn't care.
Yeah?
So how do we foster that cross-discipline accountability without having this flat note hierarchy structure or having this top-down structure? Where is the happy medium in here where we can really say we all live and die together based on the success or failure of the feature, the product, the company?
Well, these, I don't know if I can repeat that. Was that loud enough for people to hear? Okay, so the question is, how do we get, a team to work together as a unit? First of all, it's about the size of the product. I was working with a medical device company, and they did like an implantable defibrillator. And I'm telling you, they needed thousands of people for that product. At least they seemed to. And it was almost impossible to imagine how they could all work as a single team. When you have a product that is of a size, that you can get somewhere under 100 people's arms around it and have it completely include everything necessary for that either product or subproduct, then you have a prayer of a chance. But if you need thousands of people, I have no clue how to do it. But when you can have teams that are 20 or 50 or 70 people and they care about this one single product and they really, really are invested in it,
But how do you make them care equally?
how do you make them care?
It's a serious question.
It's the exact question, but it's the wrong way of phrasing it. How do you create an environment in which they are passionate about it? Is the real question. And so, well, yeah, but no. You don't tell people they have to care. I'll tell you that for sure. Ain't work. Right? There's something to be said for volunteerism. I mean, the most passionate teams I ever worked with at 3M were ones that were volunteer teams. But even if they weren't, if you have relatively small divisions, even in a big company, that kind of live or die within a group of people that know each other and they know that their whole, ability to be successful is tied up with this group of people and their future is all in this manageable group, then people can get invested in the success of that as long as, if they do, first of all, it's likely to be successful, and second of all, there's something that will come of that success. I mean, they're not just going to, it's time for you to go off on another team. That's a really good way to lose passion real fast. But people can build passion around something if they have the challenge by somebody who cares about that. I mean, I think we don't do enough to create an environment where people are passionate about making something successful. Let me just give you an example. So one of the things that I was learning recently that we can learn from the open source community is that when people work on open source, they actually care about it. They're passionate about it. And they're not doing it for money. So everything we have about the rational behavior of people, and they only do something if there's some rational return for it, sort of gets tossed out if you take a look at what goes on in open source. People that are working on that care about the product that they're working on. They care that it's a success. They care that their contribution, if something is wrong, they'll come back after a long time and go in and try to fix it if it's giving problems. How does that work? How come people are passionate about open source stuff and not about their work? Anybody got any ideas? I mean, it's not like I have a magic answer.
Well, that's because money is very narrowly understandable, source of satisfaction.
Yes,
It's not all about money.
it sure
They
isn't.
get their share of satisfaction and appreciation.
It's about empowerment. Empowerment.
Yes, where people get to be, you can either be autonomous on open source or at least you get the option to opt out. How many of you get to opt out of your assignment at work? Somebody here had a comment. Yeah,
You said the word autonomy, I mean, it aligns with their purpose, why they're interested, right? They have autonomy, and they also have an environment to demonstrate mastery as well, too. which is
right,
The theme of the book called Drive.
right.
It's about intrinsic motivation. Something we should
So if we think about open source as sort of a precursor or sort of a hairbringer of, or a bellwether of a different kind of behavior than the standard rational behavior that we're supposed to have. And it says, wait a minute, people behave differently. And here we are in the software industry. We understand open source better than almost anybody else, and yet we don't understand it at all because we are not creating environments that create the same kind of passion that attracts people to work on open source stuff in our companies. How do we do that? Yeah.
Tell a story about our tour of Hamburg. This company,
Oh, all right. I shall do that. When we first went to Hamburg in 2004, the one that did the video company, the first thing was that Ulf Mandel, I think, he had invited us to do something. We thought it was a class, but it ended up being, interviews with project teams. And he said to us, so what we do at this company, as everything we do at this company is to make it, you see the screen here? See? I'll even turn it like that. Everything we do at this company is to make it possible for people to communicate with the screen. And then he invited the Vice President of Marketing to come in and talk to us. And the Vice President of Marketing started out his talk with saying, everything we do at this company is to make it possible for people to communicate using this screen. And our biggest competitor is Polycom in the US and on and on and on. From a marketing perspective. And then we went on a tour. And we were walking around and we went into a hardware area and there was somebody working with hardware and Ola said to her, why don't you show Mary and Tom what you're doing? And she said, well, what we do in this company is we make it possible for people to communicate using screens. And we know something about that. We know that they need such and such a resolution and such a refresh rate in order to communicate well, otherwise they won't communicate. And we've decided to do a lower cost system, means we need a lower price point on the camera. We've been buying OEM cameras up till now, but we can't find one with the refresh rate and the resolution we need at the price point we need for our lower cost system. So we're designing one, and here it is, and I'm testing it. And its refresh rate right now is thus and such, which is just short of where we need to be. And its resolution is thus and such. And she went on from there. She was a tester of a hardware camera, and she knew every reason why she was testing it, what its targets were, and why the company needed it there. We went into project teams. My project team, the first one, they said, well, you know what we do? We make it possible for people to communicate with screens. That's cool. Now, one thing we know about that is that when people are communicating with screens, they do not want to be distracted by the menu to set up. It has to be completely intuitive. Another thing we know is that they're going to be in different countries all around the world. And that means that this menu, which we are designing, has to have all kinds of languages in it. Now, our competitor, Polycom in the US, they don't get multiple languages like we do, but we're in Norway. So on any team here, we have 7 or 8 languages, so no problem. We're sort of naturally multilingual. So we've got this advantage, and we've got this really intuitive screen, a menu, and on like that. So they knew why they were doing stuff. They didn't have a list of requirements that says these 7 languages. They had a we have people all around the world that are going to be using this, and we don't want to distract them with language problems, so we're going to make this, natural right from the start. And that team was not just doing stuff, they were trying to figure out how to design that menu so that it would work. So at this company, every single person that we talked to, every single one knew why they came into work in the morning. They had a very clear idea in their head how what they were doing that day was contributing to how the company was going to be successful. And it's that, I think, that that when you see people who really care about their job, they know why they're coming in for work and they understand how it's going to contribute to the success. Yeah.
So would you say of all these companies that we talked about that are good examples of innovation, were there any that were bad at vision?
There are tons of companies that are bad.
3M, Pixar, Apple, the company you just spoke of.
3M is not a company. It's a bunch of little divisions with smaller teams.
Right.
Some good, some bad.
But the V word.
What?
You just spoke to just now was it
Oh, at
started with
Tandberg?
a vision, right?
Yeah. And they had a guy that founded the company in about 55. We spent a whole afternoon talking to him about his vision and how he found it. And he said, the most important thing I do here is I tell people no. Because we have to just do a few things and focus. Now, if that sounds like Steve Jobs, it's not an accident. So it's not do whole bunches of stuff. It's do the few really important things that matter. And somebody that's the leader that's driving people to understand the few important things that matter, and then the rest of the group figuring out what that means and making it happen. So it's not without leadership that you do this.
Vision and focus.
Vision and focus are the same concept. I don't see any difference, actually. Any more questions? I'm not going to do the last section because I've been talking enough. We will. Yeah, yes.
It's also an open question. For people here that are using the Agile Scrum standard methodology, how are you working design into the actual process?
So what do you mean by standard?
So what I mean is people usually have their backlog and they say, okay, these are the 10 things we're going to focus on for this iteration. They go away.
You're thinking in 2-week chunks is just like way too small.
Absolutely, but even if it's longer, I'm curious because I've seen different people tackle the design side of things differently. So one option is they say, okay, these are the 5 or 6 things we're going to focus on for this iteration. Designers, developers, let's all work together, get it figured out. And then I've also seen alternatives where people will almost have a shadow iteration that happens first, where they do all the design work, but then the challenge is the developers don't get enough involvement typically in that phase. So I'm curious how people are tackling the...
So thinking about things in 2-week iterations is interesting from an implementation, but it's just not enough to have a vision in 2-week iterations.
No, absolutely. I'm not trying to distill.
And then of course I'm not a very big fan of backlogs either, nor am I a fan of product owners or anything like that. So I'm not sure what I should say actually. Yeah. Pardon? Okay.
Related to that, since you don't like 2 weeks, what do you like?
Well, I like 3 months. Okay, because all of the major products that I've seen anywhere in the world that are, big, I'm not positive about airplanes, but I am positive about cars. I developed in integration points of about 3 months. So for example, at Toyota, first 3 months is design structure plans, and then first clay model, and then second clay model. So I think of 3 months as a good chunk of time that a senior person should be able to estimate what can we do in 3 months, okay? And what piece of our picture puzzle can we be at 3 months from now, and then synchronize across and see how we're there. But that doesn't mean you can put a product together in 3 months. If your product is going to take you a year, like our process control systems did, then you synchronize in 2 to 3 month chunks to figure out how to get 2 months done and 2 months done, and get out there.
But it seems like most of your projects have some physical element to it, like process control, electrical, like
Right.
when it's just pure software, like SaaS product, something along those lines. Like, you still think 3 months is a
I think the more pure software it is, the less likely it is that you need a, you still have to have a vision of where you're going. Like if you look at what's going on in the world of lean product development, it's almost exactly the opposite of what's going on in the world of lean software development. What they're saying is, we're missing this fuzzy front end. We're missing the time to understand what we're doing. We are not thinking before we act. We're just creating product without understanding the problems that we need to solve before we create it. We are not investigating multiple options. We're just doing something and seeing if it works. And where you might be able to get away with that in software where things are easy to change, it's not too easy to get away with that approach when you're doing something that's hard to change. And so the strategy there is much more, why don't we acknowledge that there is what Tom was trying to tell me about fuzzy front end. There's a front end where you have to understand the problem you're trying to solve, the options on the approaches, and have a strategy. So for example, at Toyota, a chief engineer told us that before they start a car, they take the chief engineer and a small team takes a year working with the section managers, that would be the competency managers, like structure and engine and transmission, to come up with how do I create this car? What kinds of things are possible in this new car? And then they put together a proposal. They reach agreement, put together a proposal, passes the board of directors. At that point, then they implement it rapidly. And so before you actually are going to start doing something, where's the architecture that you know, that you have some idea of where you're headed? I think we've just lost the whole concept of having any architectural strategy before we start implementing. And I think that's a big mistake. If we start doing stuff in 2 months, 2-week chunks, I can't tell you how many places I have run across around the world that after 3 years of Scrum, they have a great big mess. No architecture, no tests, no nothing. And it's a disaster. Now, I've seen this disaster before. In the 80s, it was called user programming, and it was 4th generation languages. And they lasted 2 or 3 years, and then they went the same way. Why? No architecture, no structure, no thought at all. Let's just do something fast. And if all Agile is going to be in Scrum is let's hurry up and do something 2 weeks at a time, doesn't matter what it is, let's make stuff happen, that's bad. That's not going to get us anywhere.
Would you advocate an architectural board? A board of senior designers and that would...
I advocate an architect that's deeply involved in the actual implementation, not somebody that dumps it off on the team leader. Now, when you're inside of an enterprise, maybe, but when you're basically putting a new product on the market, architecture is just part of the whole thing that you need as a package. And who's ever there can as much be the chief designer through the whole time as not. And it doesn't necessarily require time, it requires a vision. Where am I going to go with this? Why? You know, what is the structure that will have playing power a long time after, you know, I get the first part done?
I'd like to try and tie your 3-month iteration idea with this gentleman's 2-week iteration concerns, which are valid concerns about the shadow sprint ahead. And then there's also, after the sprint is over, there's also the issue of, well, has the documentation really been done, and has it really all been automated, the testing automated? And in fact, you have to do that at the feature level. And maybe I could tie it, oh, the lady's gone, but she was asking, how do you involve the whole team on this stuff? And what about involving the whole team at the release level, or the quarter level, or the 3-month level, instead of just at the sprint level? I think that's where Scrum falls down. They focus too much on the 2-week iteration, and they forget about involving the whole team at the release level.
I would divide it into a couple of things. There's product software, where I'm going to actually put a product on the market that actual people are going to use. And then there's maybe infrastructure software, okay? And if I'm going to make software that's going to be a product, then I'm looking for a product team that understands how that product is going to succeed in the market, what features it needs to make a success, where it's going to go for the next 5 years, how it's going to make the company money, what is important and not important about that product moving forward, how does it fit into where the technology is moving in the future, you know, all of that stuff. And I think team members should know that and be a part of those discussions, okay? If it's something different, if it's not a product that I can, you know, get my hands on, price, see its economic returns to my company and something like that. If it's more infrastructure stuff, I have a harder time figuring out how to say the team should have a very good understanding of why this thing is important. But I still think they should. And it's not a 3-month versus 2-week thing. It's understanding why. What value for people sits in this work that they're doing. I like this concept of tie work to value. When I come into work, I want to know what value I'm delivering to somebody for some reason. I want to care about that. And so sometimes 2 weeks is a sensible chunk. Sometimes 3 months is a sensible chunk. Sometimes you do what Dropbox does and it takes 18 months before you have a releasable chunk. It depends upon what are you trying to accomplish with it. What is the short-term and long-term goal? Not just short-term, but long-term goal. How do you get the team involved in making sure that over time it delivers value to the company and to customers and is successful? And it's that conversation we're not having. We're not talking about that. It's too much of what am I going to do in 2 weeks? And somebody will tell me what to do in the next 2 months instead of let's understand why this is important so that we can make wise decisions about it. Someone?
Do you have any idea how long, if Dropbox did this in one sort of waterfall chunk, or if they...
I don't think waterfall is the correct word.
Or do you think they did it in small pieces? And just release once they get...
The guy that founded, I can't remember his name, Houston, yeah. Went to MIT. When he was at MIT, he could go to any computer anywhere and just log on and his environment was there. When he left MIT and got a PC, he discovered that the rest of the world didn't act that way. And he was appalled. And he said, you know what? I want to bring my, when I log on, my environment is there thing from MIT to the rest of the world. I think it's missing. That's the vision he had. Okay? And when he had that vision, and he was on a train and he put his stick into his computer and it was empty and he lost his entire train ride when he, 4 hours when he needed to do some work because he had a deadline. And he says, the world is missing something and I'm going to supply it. But there were plenty of ways to sync computers. None of them worked very well. And so he was going to put together a way to sync computers that worked beautifully. And he decided with his colleague, who was also a technical guy, that he would create something that would take every operating system and device that was known right now today out there, and if you plugged it in, it would sync, if you told it to. So that was his design goal. And until everything out there was ready to sync, he wasn't going to release it. He knew he had a vision of exactly how it was going to work, and he said it turned out to be a lot harder than he thought. But he also knew that people would love it if it did what he said it was going to do as easily as he said it was going to do it. And so he did all the work necessary till it was working right before he released it, because he probably correctly guessed that if he did mini releases of half-baked stuff, betcha 90% of you wouldn't have ever heard of the word.
But does that mean that they didn't consider each other's pieces for that? Or would someone still say, okay, we think we've got this thing working on the Mac, we'll talk to you guys in 4 or 5 days, and that they do?
There was a very small development team just inside, and nothing was released out of the company at all until it worked all over.
Yeah.
Because they made the decision that that was fundamental. So when you're ready to release is a very interesting question. And I wouldn't call that a massive waterfall. I would call that a very wise guy that understood that this thing had to be at a particular state when he released it if he wanted the whole world to fall in love with it immediately. And that was at least half of its marketing. And it's that vision. There was no data you could have collected that would have told him that. He just knew it in his head. It was that vision of what did this have to do for people like I had when I was at MIT. Had to be that good. What does it have to do to get to that state? And until it's at that state, I am not going to let anybody outside of my tiny little people that are working on this company even see it. So, and it was not a vision of how much work it took. It was a vision of how intriguing it had to be, how easily it had to work, how flawless it had to be in order to capture the imagination and the confidence of all of the people that were going to use it. Just different. Oh, I'm ready to leave any time, so maybe we should I'm done.
All right, thanks so much.
I will just